In this recording, we're going to look at an application of quadratic functions, and we're going to do that by doing the question that's called checkpoint 5 on page 331 of our textbook. We're given this quadratic function, f at x equals negative 0.005 x squared plus 2x plus 5, where x is the horizontal distance that the arrow has flown, and f at x gives the height of the arrow. So the first part of the question is, what's the maximum height and where does it occur? So if you think about a quadratic, the a value, the coefficient of x squared, is negative, so this is a parabola that opens downward. And so when we want the maximum height, we're really looking for the vertex. So this is where we can use that vertex formula, where we know that x is negative b over 2a. And if we use our b and a value from here, we get negative 2 over 2 times negative 0.005. Watch the signs here very carefully. And we get x equals 200. So that's 200 feet from where it was shot. And that is the x value of the coordinate, so that tells you where it occurs. But to find the maximum height, we'll substitute that value for x into f at x. So f at 200 now will be negative, and we'll just substitute all those values in, 0.005 times 200 squared plus 2 times 200 plus 5. And we'll get f at 200 equals 205 feet. Okay, so the maximum height is 205 feet, and it occurs when the arrow has flown 200 feet horizontally. B part of the question asks, what's the horizontal distance to the ground? So how far does the arrow fly before it hits the ground? If you think about the arrow hitting the ground, that gives us the height of 0. So we can substitute 0 in for f at x then. So 0 equals negative 0.005 x squared plus 2x plus 5. And looking at that, trying to solve that quadratic, it does not look factorable to me. So I would use the quadratic formula and substitute the values in, and we'll have negative 2 plus or minus the square root of 2 squared minus 4 times negative 0.005 times 5 all over 2 times negative 0.005, and using a calculator we'll get two values for x. We'll have x is approximately 402.5, and sorry, I should use the wavy line there, and x is approximately equal to negative 2.5. We can discard the negative value because the negative horizontal distance for the arrow does not make sense. So the arrow flies approximately 402 feet. So approximately 400, and because this was 402.48, so 402 feet is the distance the arrow flies before it hits the ground. All right, and the third question was to sketch the graph, and this will be a pretty rough sketch. And if you think about what we already know about this graph, we know that its vertex is at 200 and 205. We know that the x-intercepts, well, the one is at 402 feet, and there's also a negative 2.5 feet approximately. But we won't sketch any of the negative values because they don't make sense for this question. And we can also calculate very quickly our y-intercept. If you plug x equals 0 into the equation, very quickly you'll see that the y-intercept is 5. So now we have enough points to go on to make a fairly rough sketch of this flight of this arrow. So our y-intercept is at 5, so that's the 0.05. Our x-intercept is at 402, so that's the point 402 and 0. And our vertex is at 200 and 205. And we can put the vertex there and then use a smooth curve to join those points together. Okay, and that's a sketch, again, a very rough sketch of the flight of that arrow. And that's it for this one.